All right. So again, for the agenda and your reminders, you can see today we're going to practice again with some electric force and gravitational force problems, just kind of warming up with some review. And then we're going to continue to make sure you understand gravitational field, just reviewing a few concepts and showing you a few kinds of questions you would likely see on an AP exam regarding that topic of gravitational field. And then we will have some time to work. So you're going to have some time to ask some questions about worksheet 3. You're going to have some time to, if you don't have questions on that, work on your lab report, which is due next time on, today is Wednesday, so Friday. So the worksheet 3 is due today, but you're going to have a chance to ask some questions. And if you have that done, you'll just turn it in and you can work on your lab report, which is due Friday. If you're done with your lab report or you finish it during that work time today, then you should start working on your next assignment, which is due next Tuesday. And I'll go over that here in a few minutes. So you can see all these assignments on Access. They're already all posted. You can look at the descriptions and see, exactly what to do for each one. But I want to make sure you're aware of the timeline. Worksheet due today, lab due Friday, and then we don't have school next Monday. So on Tuesday is when you will be required to finish up the AP classroom work. So let me go ahead and show you on AP Classroom what the work is, so you're aware. And I know we haven't used it a ton, but we're going to be using it quite a bit more this semester. So I want to make sure that you can see how it all fits together. Some of you have been, I can see how much you're on there from my side of things. It shows me your usage and which videos you've watched and things like that. So I can find much on it prior. Many of you haven't used it much. So I want to make sure you're really clear on how to, because it will be much more common. You're going to have homework here this semester. All right, so it'll be account here. It lets me do like a student view. Is there someone look? Okay, Dominic. All right, because your student view looks a lot different, even to the point where when I make a name for a quiz, it shows it different on mine than it does on yours, which is bizarre to me. But it gives you a place where you can name it, and then when you do that, that's what it looks like on your side, but on my side, it doesn't. It looks like something different, so it's really weird. But all right, so let's see, we're section 2. Dominic said we could use his. Okay, so yours should look something like this. When you go to the home page, you're going to see just this long string of things, which is basically everything that's been quote unquote assigned. It hasn't always been assigned for a grade, but if it's something that I'm encouraging you to do or requiring you to do, it's going to show up there. And so first semester is mostly I'm encouraging you to do these things. Okay, this semester it's going to be mostly I'm requiring you to do these things. So you'll probably have a lot of stuff up here if you didn't use much of that I encourage you to first semester. So what I would say is go to My Assignments and then pick Active. And it will show you the most recent assignments at the top. And these are the ones that you need to do by next Tuesday. Okay, and so it's just watch this video. Pretty simple. But I will comment that I've been using this quite a bit more in AP Physics 2, even last semester. And if you don't watch it all the way to the end, because usually towards the end of the video, they'll start wrapping it up and they'll say, next time we're going to talk about this. And a lot of times students stop it there. And if you stop it there, it doesn't record that you watched it, or it'll say you watched like half of it. It won't say that, even if you only have a few seconds left. So just let it run all the way to the end. Otherwise, it's not going to give you credit. And there's no way for me to know. So I can't tell if you really watched half of it or if you watched 90% of it. And so just let it run to the end so you are sure to get full credit when you watch the videos. And so the first part of the AP assignment is to watch these 4 daily videos. They're, I think, all less than 10 minutes. And so you can just watch them little by little between now and next Tuesday. For you guys, it'll be Wednesday, next Wednesday. And then you also need to answer these 12 multiple choice questions in the Gravitational Force and Field quiz. Okay, it's not a quiz grade, it's just what College Board calls it on here. It's called a topic questions quiz. So, but it isn't a quiz grade. It'll just be basically a completion grade. All of this is a completion grade. You watch the videos, you complete watching the videos, you get the points, 5 points per video. If you attempt all 12 questions and it appears that you've put in a legitimate amount of time, if you attempt all 12 questions and I can see you did that in 30 seconds, then that's not really what I'm looking for, right? You just went through and you didn't read the questions if you answered all 12 in 30 seconds. But if I can see, yeah, you used a reasonable amount of time, you were obviously trying to do something here, even if you didn't get very many of them right, because they are AP difficult questions. It's not how many you get right, it's are you investing a legitimate amount of time, not 30 seconds, in answering them, okay? And if you do, then you get full credit. So watch these 4 videos, answer these multiple choice questions for next Wednesday, okay? And like I said, today you're gonna have some class time to work on any of that. So if you are already done with worksheet 3, you'll just turn that in and finish up your lab report. If you're already done with the lab report, you can turn that in, or you can wait till Friday, because it's not due till then, and just work on AP Classroom, because you'll probably have about a half an hour, maybe even more time to work in class today, okay? Which is rare, we don't generally have that option, but we've got several overlapping assignments right now, and I know a lot of you have questions on worksheet 3, and so I want to make sure you have time to get some of those questions answered, okay? Any questions about timeline or what the assignments are? All right, very good. So let's practice with some review. And then, like I said, you're going to have a good chunk of time to get some work done, get some questions answered, and hopefully feel better about where we're at. Before class, a couple students were asking, where are we in the unit? Like, how long is it before we're going to have a test? We're kind of wrapping up some loose ends from Unit 2 on forces, because we covered electric force and gravitational force. But we're also kind of entering into Unit 3 with gravitation. If you look at the title for Unit 3, it's circular motion and gravitation. So we're kind of straddling the fence in both units right now. And I would say after today, we'll have covered roughly a third of Unit 3. And so next time, we're going to actually do a little bit more review on Unit 2. Based on some of the things that I'm seeing in terms of the questions that students are having about the gravitation problems, I'm feeling like we probably need to go back and try some more challenging force problems to really shore up that. I feel like there's still some weakness in certain areas of forces and really understanding those. And that's such a key component on the exam. I don't want to let that slide. So I think we're going to do some more review on forces in systems, whether it's gravitational systems or otherwise, to make sure you're really confident, or at least more confident. And then we might start introducing the idea of circular motion on Thursday as well. But there's kind of a little, again, still straddling the fence, a little review with a little bit new on Thursday. And then next week we'll be fully into Unit 3. I doubt if we'll be able to finish Unit 3 next week though. So the test would probably not be next week, but the week after. Okay, so that's kind of rough timing. All right, so let's do these warm-up problems. The first one is electric force. And I have, as I've been digging through AP Classroom, because it's different this year since they changed the curriculum, they've made some changes on AP Classroom, but I'm still seeing electric force show up here and there. And so while they've, again, taken the equation off of the formula sheet, they've left the constant on, and there's still some things here and there on the AP Classroom site, even though they've deleted some, they've left some. So I still feel like we should just do maybe one more practice problem on electric force, just to make sure in case it shows up for you in May. So here you go. Let me get this uncovered here. All right. So again, this K value is provided. That's on the formula list, but this equation is not. All right. Now it is very much like the gravitational equation, which is provided, but you have to substitute out the Q's, or you have to put these Q's in when it's charged and electric instead of mass when it's gravity. And then instead of K, it's G. So a couple little changes, but the same pattern. But like I said, I just feel like there could be a question on the exam. So this one says we have a negative 4.2. What's that little funny U shape mean? Times 10 to the negative 6 power. And if you're, again, not confident with metrics, they've got a little metrics prefix here on the formula sheet. It tells you micro right here, shows the symbol, tells you 10 to the negative 6. So you can look that up. A negative 4.2 microcoulomb charge exerts an attractive force of 1.8. What's MN? Millinewtons. And if you're not familiar with milli, it's on here, times 10 to the negative third. So you can check that out. On a second charge, which is a distance of 2.4 meters away. What is the magnitude and the sign of the second charge? Well, the magnitude is going to take some calculation, but we should be able to discern the sign based on the first sentence. What should the sign of our answer be? How do we know it's positive?
Because one is negative, and if it attracts it,
Good. If we look at the details in that first sentence, we can see that this is a negative charge, okay? And then it says that the force is attractive. Opposites attract. So if this one's negative, the other one has to be positive, right? So it has to be one of these two, right? Can't be negative, otherwise they would repel each other. Okay, so we know it's not this and not that. So we've already narrowed it down to 50% without doing any math, okay? So exam taking protocol, test taking skills, if you're running out of time on the multiple choice and you see a problem like this and you just don't have time to plug in all those numbers to make sure you get it right, at least you can narrow it down to a 50-50 guess, okay? Because it's better to answer every question than to leave any blank. Because you don't get penalized for wrong answers, but you do get penalized for no answer. Like, I mean, you don't get penalized negatively. Like if you get it wrong, you just miss it, but you don't get a negative penalty for that, like on some exams. Okay, so you don't want to leave it blank. You want to give a guess, and if you can narrow it down, you got a better chance. Okay, just test taking skills. So we know it's going to be positive. So go ahead and use your calculators, plug in the numbers. Don't forget your micro and your milli, and you can use the K value that's here on the screen, or you can look it up on your formula sheet and see what you come up with. Is it C or is it D?
definitely D. Yeah, C. Oh, see. In that case, I choose C. C for sharp. Always go with the letter that starts your name.
So only one of you is going to get it right.
Oh, yeah, exactly. It's gonna be. It's all about willpower.
Once you've had a chance to plug in the numbers and get an answer, just let me see your hand. Just, you don't have to keep it up, just so I can see timing. Okay, we've got a couple people done already. Yeah, another minute or so for those that are working.
Yeah. My name. No way. Yeah. No, I definitely did it wrong.
How many are done now? We have a few more, hopefully. Okay, so give me a little more time then.
Oh, it's 9. Oh, that's why I messed up. Then that's divided by 4 squares. No.
No?
Yeah. So if you divide that by 6.4, then you can get this as a fraction.
If you're not getting the answer for C or D, make sure you're not forgetting the micro for the negative 4.2, and you don't need to worry about the negative because it is absolute values. Make sure you're not forgetting the negative times 10 to the negative 3 for your newtons. Make sure you're not forgetting to square the distance, r squared in the denominator. Those little details can kind of catch you sometimes.
Yeah, yeah.
So the question of the day, is it Charlie or is it Dominic? Is it C or D?
Dominic.
How many agree with D? Okay, got several hands going up there. All right, so
want to, but.
Don't want to, it's hard to give in, huh? All right, so here is the setup. Now, College Board, again, I mentioned this before, they encourage you to, well, you have to write the equation almost always for the first point. If you don't write the equation, then you generally are gonna be losing a point. And almost always they require that you substitute as well. They encourage but don't require that you do the algebra first, but you don't have to do that. It's just their strong encouragement. So here they've taken the equation, they've solved it for Q2. Now you could have solved it for Q1, it doesn't matter, they're interchangeable, but they called it Q2. And that means it's going to be the force times the radius, or distance squared, divided by K times Q1. So the force is that 1.8 millinewtons, so times 10 to the negative 3. The distance was 2.4 meters, but we got to square it. K is given, it's on the formula sheet. And then the first charge is 4.2 times 10 to the negative 6 coulombs. And again, you can drop the negative, we just use absolute value. So we know the absolute value of the charge is 2.7 times 10 to the negative 7 coulombs. But based on the wording in that first line, we know it has to be a positive charge, otherwise it wouldn't attract. All right, any questions on this practice? All right, so again, that's probably the last one that will take class time to practice, because I will have one question like this on your coming exam in a couple of weeks, but I don't know for sure if it's going to end up on the May exam, and so I just want you to be ready for it in case, but I don't think we'll probably take any more class time on this. So if you're still needing help with this kind of problem, let me know and I can try to help you work through that. All right, let's go through a couple of gravitation problems then. So what is the magnitude of the gravitational force between the Earth and its sun? Okay, so here's your equation. Here's the value for G. You see the distance between them and their masses. So a little bit of practice with the gravitational force equation. Can you have an answer? Show me your hand so I can kind of see timing wise. Okay, get quite a few. Give you another 30 seconds or so for those still working. Oh, come on. All right, on this one, there's not very many context clues to help us predict whether we can just eliminate a large number of them. We can probably eliminate A because it shows that it's a really small force. And if we look at the exponents in the problem, it looks like that wouldn't make sense. But for B, C, and D, we're probably gonna have to do some math to figure it out, at least with some exponents. So what do we come up with? D, yeah, it is D again in this case. They don't show the work here because it's pretty much the same type of a thing. You're going to plug 6.67 times 10 to the negative 11 in for G, 6 times 10 to the 24th in for M1, 2 times 10 to the 30th in for M2, divided by 1.5 times 10 to the 11th squared. So this one's just a plug and chug, plug the numbers in, chug them through, get your answer. All right. what is the magnitude of the gravitational force between the Earth and you? Right, so here you can see the radius of the Earth, which would be how far you are from its center. You can see the mass of the Earth. You hopefully know your own mass, but it does need to be in kilograms. So if you don't know your mass in kilograms, so 1 kilogram equals 2.2 pounds. All right, so you can convert, if you know what your weight is approximately in pounds, you can convert it to kilograms. And figure out what the gravitational force is between you and the Earth. To give you kind of a ballpark, mine comes out around 880 newtons. So most of you are less than me. But you should know if you're relative, like if you're coming in with 20 or something, that's too much less than me. So mine's about 880 newtons, 880. Yeah, my guess is most of you are going to be somewhere between 500 and 800.
I see what I did, so I used yeah,
That's
a little bit too high.
How much is yours?
It was the Earth.
880.
Yeah.
Yeah, it's probably like 600.
Yeah,
somewhere.
650.
Yeah. So here's something I want you, I'm assuming you all use this equation, because that's kind of what the question implies. But now I want you to take your mass in kilograms times 9.8, see what you get.
Okay.
Should be about the same, right? Pretty close?
Yeah.
Okay. So that's leading us into something we're gonna do here in a few minutes, is recognize where does that 9.8 come from? Well, it comes from this equation. And so if you ever needed to find the gravitational force, that's just another way to say weight, right? If it's on Earth, you don't really need to use this equation. You can just use F equals mg, right? But you can also use this equation. That's an important thing to remember coming up in a few minutes. All right. Now, here's the next project. This one you can't use 9.8, because here I want you to pick a partner and find the gravitational force of attraction, because gravity is always an attractive force. It always pulls together. Between you and your partner, if you're standing 5 meters apart, which is roughly 16 feet, if you're not familiar with meters, you can kind of picture that. Or if you're standing 0.05 meters apart, which is 2 inches, kind of a close talker situation, right? And then again, a reminder, there is 2.2 pounds in a kilogram. So I'd like you to show it on a whiteboard so I can kind of see your work, all right? So pick a partner, find out what's the attractive gravitational force between the two of you.
are we gonna write it down on the white? No, I
It's like rock, paper,
don't.
scissors. We're here to find the part. There's 3 odd men
I
out.
don't wanna stand.
Alright, so. Okay.
We gotta write down the equation and everything.
Yes, okay.
Maybe Shelton.
What is this? F, C.
We just FSG or whatever that is equals.
I think there's an automatic equal.
Okay, I might have to have a
Charlie,
group of
what
3.
was your,
Just, you like do one pair of view at 5 meters and another pair of view at 0.05.
wait, no.
Uh, 66.
66.
Yeah. No.
Alright.
You were 64?
Yeah, 64.5. Divided by.
How much do you weigh? 145. So we're both 65.9091. Okay. So, are we drawing a diagram?
I just want you to calculate it. Oh, okay. So what would the force of attraction due to gravity be between you?
2 masses.
Squared.
We got 1 point.
Times the
Whatever.
Yeah. We have to move it to kilograms, right?
Oh,
yeah. So it's 0.5 times.
If I take that answer, 70% multiplied by 5 squared, did I get where I was at before? And then say that.
exactly. Or you could just go up and like press enter on the type equation and
Yeah, it's basically just 6.67. I got 1.420.
wait for 0, what, 80 squared?
Yeah. I also didn't divide it. Wait, what were you saying was that answer?
Oh, go up to the.
Oh, no, you're right.
Isn't that crazy?
Alright, 0.
Wait, I think you guys, do we have to change it to,
Wait, kilometer.
Oh, wait. Really?
because I know we're in kilograms. Don't you just do 5 meters times 10?
Great work, Charlie. There's
I don't
so
know
much
if you
attraction
need-
between us.
I don't think we do. I don't know why you would need.
How much?
I got this one.
A lot.
Yeah.
So you guys just doing it over 5 squares?
Yeah.
No.
I wouldn't use that as a pickup line, I don't think.
Damn, I calculated our attraction. Turns out we're very attractive.
Times 10 to negative 8.
Yeah.
Dude, that means if you're like,
Yeah, exactly. No, that means if you're like, if you're really heavy, but you're like, not
We should've
big.
called
Yeah, I don't
it.
think that conversation's ever gonna go well.
Yeah.
No, it's fine. That's why girls like guys. Yeah.
That's true, more attraction. Yeah, let's see those lean muscles. Oh, you, right?
You're the one number. Can't wear that sweatshirt without you.
I don't know. Let's see. In the definition is.
Bro, I have no clue what unit this is.
You hit the.
Now that you brought that up, I have
Come
no
on,
clue.
man. I'm get on like line. I'm going during lunch.
What are these?
Oh. You like everybody?
No,
no.
I mean, you guys
Oh,
are like,
yeah. So on.
They're not that
Wednesday,
weird.
Thursday, we work out.
What are you coming up with here?
That's the answer.
4 or 5 meters?
Yeah.
Okay, find it for 0.05.
Yeah.
Literally, you just need to pass in, don't think a bit of got shot off. It would have been open.
All right, I think that everybody has figured it out, so let's go ahead and put the whiteboards back, and then we're gonna have a little conversation about that.
I gotta take a picture of that.
Okay, now I'm prepared.
I got it right there.
You guys have a very low attraction.
that's hot.
Eli, what's your attraction?
We got like 1.606.
It's 1.606.
Oh, times like 10 today.
All right, so just to kind of bring home how small those values are, I just did a quick converter here rather than taking the time to walk through all the conversions. So most of you had like 0.0001 newtons of attraction at 2 inches apart, pretty close, right? And so somewhere in that ballpark, and as your masses change, that number's gonna be different, but it was relatively in that ballpark for most of you, which means it's 0.00002 pounds. Okay, that's how much gravitational force. That's why we don't feel that, because you have to be 2 inches apart to feel that much, right? We're not usually 2 inches apart from other people. I mean, that's not too common, and so any farther it just gets weaker, and it gets weaker quadratically, inverse quadratic, right? So just to kind of think through that, attraction due to gravity is very weak. That's why we don't feel it. The only reason we feel it from the Earth is because the Earth's mass is so huge. All right. So as we were joking back there, this isn't a great pickup line. You don't. I mean, even if they're nerdy, you don't really want to talk about your gravitational attraction to them, because the only way it grows is if they get bigger, and then you start talking about their weight, and then it's just not.
It's like density.
I mean, yeah, yeah, another one I wouldn't use. Yeah. All right. Okay. So the last thing to review here, gravitational field. So gravitational field is G, little g, lowercase g. All right. And we've talked about it as being an acceleration almost all first semester because we were focused on kinematics. But now we're learning about gravity. We've stepped into Unit 3 and we're crossing over into some of that territory. So here's a couple things I want to make sure you understand about lowercase g that we've not spent as much time talking about. So we've called it acceleration due to gravity, and that's actually what College Board calls it too. If you look on the formula sheet in constants, it says right here, acceleration due to gravity, g equals 9.8 meters per second squared. So that's what they call it, but it technically is the strength of the gravitational field as well. And so from your lab the other day, you found it in newtons per kilogram, which is force per mass, right? So that's the amount of force the Earth exerts per kilogram on an object because of its gravitational field. A gravitational field, or any field really, is the way the space distorts around an object. A gravitational field is the way the space around an object distorts because of that object's mass. Okay? An electric field would be the field around an object that distorts based on the object's charge. All right. Now, electric fields, we're going to save it for those that might take AP Physics 2, but for gravitational field, we have to have at least a little bit of an understanding about that. So on this screen, you can see an equation where you can actually calculate it. Now, if you take G, 6.67 times 10 to the negative 11, times m, the mass of the Earth, 6 times 10 to the 24th, and divide it by the radius of the Earth, I forget that number, and square it, that gives you 9.8. Okay? If you take the mass of the Earth and the radius of the Earth and square it and plug it in here, you get 9.8. That's where it comes from. That's why when you found your weight earlier using the new equation for gravitational force, and then you found it just taking your mass times 9.8, you got roughly the same answer, because this gives you 9.8 if you plug in the mass of the Earth and the radius of the Earth. All right. Now, over here on the left, it says, while the force between objects can always be computed using the formula for Fg, we found that, it's sometimes convenient to consider one mass as creating a gravitational field and the other mass just responding to it. And so here they're saying if you just split this equation up to where we've got gm1 over r squared and we separate out, so like this is the Earth and this is you, kind of a deal. We're just separating the small object out and considering how the Earth impacts you because it's so much more massive. We can think about that being the weight, and we can substitute and actually find the weight either way. Okay. Now, to me, this kind of skips some math steps that I think may not feel very intuitive. So I've written it out with a little bit more detail on the next slide. This is how I would try to think it through. We've learned last semester that you can find your weight on Earth by taking your mass or any object's mass times 9.8, the value of G on Earth. That's how we did it all last semester. Now this semester we're learning, well, you can also find your weight on Earth by taking capital G, the gravitational constant, times your mass times the Earth's mass divided by the Earth's radius squared. Now we've got two ways to find your weight on Earth. But since they're both your weight on Earth, we can set them equal to each other. And this is kind of the step that they skipped over on that previous slide. So it would be your mass times little g on Earth, 9.8, equals capital G, the constant, times your mass times the mass of the Earth over the radius of the Earth squared. Well, notice that your mass cancels out because it's on both sides of the equal sign. So the value for G can always be calculated on any planet by taking capital G, the gravitational constant, times the mass of the planet, in this case we just happen to be talking about Earth, divided by the radius of that planet squared. Okay, so it could be a planet, it could be a moon, it could be a sun, it can be any large astronomical object, but this is kind of another proof of where that value for G comes from. So we just learned it and memorized it. It's 9.8. We just knew it. But now we're seeing, how do we know it's 9.8? How can we calculate the value of 9.8? Now, on the worksheet that you've been doing, worksheet 3, if you know, for instance, the mass of Jupiter and you know the radius of Jupiter, well, you could just plug it into this equation and find the value for G. And then use this to find the weight of objects. Sometimes they give you that information. But often they don't give you that information. They just say it's this much more than the Earth, or it's this much less than the Earth. They just give you a proportion, right? And I think that's what's tripping many of you up on the worksheet, is having to think proportionally and process those questions without numbers that you can just plug into an equation. But if you understand the background of this equation, I think it's going to help you on some of the problems that we're going to look at. All right. Last little bit here on gravitational field. Can I get someone to read this slide for us? All right, thanks, Aiden.
The magnitude of the gravitational field G created by an object varies from location to location in space. It depends on the distance from the object and the object's mass. Gravitational field G is a vector. Its direction is always towards the object creating the field. That's the direction of the force that a test mass would experience if placed at that location. In fact, G is the acceleration that a mass would experience if placed at the location in space.
All right, so it's giving you a little bit more concept about the Earth's actually just creating this field that goes out to infinity, and the farther the object is, the weaker that field strength would be, but the closer the object is, the stronger that field strength would be in a quadratic way, because we can see that the distance is squared here in the denominator. So as we are right on the Earth's surface, we're close, right? So we feel a stronger gravitational field. If you're in the International Space Station, the field is weaker. If you're on the moon, the field is weaker, okay? But it continues to, because the Earth is so massive, it does continue to experience or create that field, not technically to infinity, but you can kind of think about it that way. It just keeps getting weaker and weaker and weaker, like an asymptote never reaches the line kind of a deal. All right. Now here is one kind of question I've seen on the AP exam fairly frequently. Where is the gravitational field the strongest? So we've got some planet, sun, moon, big object in the middle, and then we've got these little other objects surrounding it, satellites, moons, whatever they happen to be. Well, where would the gravitational field by that large object be the strongest?
A.
And why at A?
Closest to the sun.
Because it's closest. When we found the value for G, if we go back to my proof here, the mass of the object cancels out, right? So it doesn't even matter how massive the object is. It doesn't matter what the mass of A, B, C, D, it only matters what the mass of this is. Okay. And so, and then the location. So A is closest, it's gonna have the strongest. B is probably next, so it's gonna be next strongest. C looks like it might be the farthest, or D maybe I guess is the farthest, and C and E are pretty far. So you just see these field vectors being strongest and then weakest the farther they are away. Okay, so that is one kind of multiple choice question I've seen occasionally throughout the years about gravitational field. All right, the other kind of question I see is proportionality, hence the assignment worksheet 3, to try to challenge you to work with proportions, okay? What happens to the gravitational field if the distance from the center of the object doubles? B?
D.
D? Which one is it?
D. Dominant.
Why D?
Because it's inversely proportional to the square.
Yeah, it's an inverse square proportion. Okay, inverse square proportion. So if you're doubling it, you have to square the 2, and then it's in the denominator, so it's going to be 1/4. So it will be 1/4 the strength of the field as it gets twice as far away. All right. What happens to the gravitational field if the mass of the object doubles?
It double.
Yeah, the mass is not quadratic in the equation, right? It's in the numerator. So as the mass goes up, the field goes up, and in a linear way. So if the mass doubles, the field doubles, right? Thinking back to this relationship, it's a ratio of the mass and the distance squared, right? So we have to factor both things in. Now, in these two questions, the first one only considers the distance. And this one, it only considers the mass. On worksheet 3, it asks you to try to do both. And that's, I think, again, where it's causing some consternation, causing some confusion. All right, now, we're gonna have some work time for the rest of the time. And for those of you that have some questions on worksheet 3, that's a chance for you to get them answered by your classmates or by me. If you're done with worksheet 3, we'll just have you put them over here on the stool. Just whenever you're finished with worksheet 3, you can just put it here. But in the meantime, if you have questions, I can come around and help you, or you can work together and try to figure it out. When you're done with the worksheet, I would encourage you to work on your lab report, which is due Friday. If you happen to have it done, you can turn it in early, but it's not due till Friday, okay? And then if you get done with both of those, then I would work on this AP classroom, watching those 4 videos and doing that quiz set of questions. You got this?
Do we need to put number 7 on the homework?
You do need to have number 7 on the homework, yes.
Yeah. Good, so.
All right, so use your time well. We've got 35 minutes here.
For each planet, and I use this.
If you have questions, make sure you let me know for any of it, for the lab, for worksheet 3.
Where were you turning the lab recording?
Lab report, you can just put them on the floor.
So what I did is like,
Yeah.
on the board there, right?
Like there's so much.
So you like put them proportional, right?
Yeah.
And you get this, right? And then you substitute in the value.
You get that, that's right?
Yeah, that's
It does equal to the other one, the masses are different. but
So
you can't-
that's the
No,
distance
yeah, they are,
and
because,
you're finding.
yeah, because the G is
Oh, R of 2, yeah, that's kind of what I did, yeah, R is
Right.
different, R2 is different.
and then you get R, what you saw for.
If your work's all on another piece of paper, you don't need to, unless you just want to keep it together. Yeah. Yeah.
You probably write like a.
Did I do
And you square.
Yeah, when you I don't know.
There's a way to do it in
Yeah.
algebra.
It's like that.
I just don't have the bars.
On this side of the sheet.
Oh, yeah. Yeah, I think that's that. I didn't see that. And I said, okay. X equals 3.8, whatever, equal 8.
Right now it's decent.
Plug that in there.
I think 6 is.
And then I just solve for R squared.
It's like number.
That's how you know.
But but that's also squared. So then I got. Yeah, whatever.
I think you just take 9.8.
That's the part I don't, you look at it, it's like algebra. It's a 9.2x plus x equals full distance.
Wait,
But you
did you
divide-
do-
oh, that's- You just do math. Algebra is big.
If all your work's here, you don't have to unless you just want to keep it together. I forgot about that.
Very good, I guys. Chris, algebra was question.
On the practice?
Yeah.
Yeah.
I always seem to get this which is, I know what I do, I just
Okay.
did something wrong in my calculator.
Sure, check it out. When we started with this one.
Right, so.
You do math.
He's right.
You should need to use solve because there's no variable. Unless, are you? Oh, okay, that works, okay.
This stuff all cancel out, it doesn't matter. But
Here's where you're getting this arrangement.
So I have,
we want to talk about.
you think we need to get these like rewritten?
But this is the charge, not the force. Yeah, because this coulombs is a charge. Newtons is the force. So that goes into the force. And that goes into one of the charges. 1.8 times 10 to the negative third. This is the Billy. Yeah.
Oh, you.
Oh, because these two are charged.